welcome to True Projects. In this video, we are going to explain about the project, that is, how do crowd users express their opinions against software applications in social media, a fine-grained classification approach. Before getting into the execution, first let us understand what is the project about. The software app market. It is growing rapidly. That too with millions of apps available across platforms like Google Play Store, the Apple Store, and also Amazon. So what does these platforms do? These platforms they offer users with the ability to search, download, and also provide the feedback on apps they use. This creates a dynamic environment for app development. So the feedback user gives, whether it may be through reviews or it may be through comments, it is essential for developers. So this helps them to identify bugs, report issues, and also suggest new features. So this continuous feedback loop, this allows developers to address the user concerns and also make improvements, ensuring that apps evolve to meet user expectations. By paying attention to user feedback, developers can refine app functionalities, they can fix problems, and also introduce new features that enhance the overall user experience. It is this interaction between users and the developers that drives the important improvement and growth of software applications. So, here with the overwhelming data, that is, with the sheer volume of user feedback that is being generated, especially for low ranked apps, this makes manual analysis impractical and also time consuming. Most of the researchers that we do so far has focused on analyzing feedbacks for popular and highly rated apps. Often they overlook the critical issues in lesser known applications. So by this neglects the users. So this neglects results in unresolved problems, user dissatisfaction, and also even in app uninstallation, which can severely damage an app's reputation. So, to improve app quality and user satisfaction, there is a clear need for more systematic methods that can efficiently identify user reported issues and also analyze the emotional responses like anger, fear, sadness, and disgust that is associated with these issues. Addressing these emotional insights can help developers prioritize improvements and also enhance the user experience. So to overcome all these issues, in this project, we are proposing a natural language processing technique. So the system that we are proposing is designed to identify common issues or bugs in software applications on the Google Play Store and understand emotions users are expressing when they report these problems. So here we use natural language processing, that is nothing but NLP techniques, to analyze user feedback and extract the main issues that users are facing. Once we have identified these issues, we use various machine learning models that are nothing but multinomial naive Bayes, logistic regression, random forest, multi-layer perceptron, k-nearest neighbor, ADA boost, and voting classifier to classify the user emotions that behind the feedback. Specifically, here we try to classify the emotions that are anger, fear, sadness, and disgust that users may be feeling due to these issues. So, to make this process work, we collected feedback data from the Google Play Store reviews from the Kaggle repository and create a ground truth dataset by using grounded theory and content analysis methods to ensure we have accurate data for training the models. This approach helps us better understand user concerns and emotions, which can be crucial for improving the app and also addressing the user dissatisfaction. And moving on to the extension part, as the extension of this project, we have used an ensemble model, that is nothing but stacking classifier, to combine the results from the multiple models. This will help to improve the overall accuracy and reliability of the prediction. This method essentially takes the strength of several individual models and combine them to make more precise prediction. And here we have also incorporated topic modeling method. So here we have used topic modeling, which is a technique that helps us to identify the most frequent and important words in the user feedback. This gives us deeper insights into the common issues that we are facing. To make the system more user friendly, here we have built front end using Flask framework. So we have developed front end using Flask framework. This includes user authentication also. So here we are also including user authentication for secure access purpose. This frontend allows both the software vendors and users to easily interact with the system, enabling them to analyze feedback and use the insights to improve the software-based prediction. Moving on to the implementation of the project. To implement this project, we have followed the steps in the flow of work. So first, we start by importing all the necessary Python libraries and packages that are required for data manipulation, model building, and also visualization. The next step is we explore the dataset. We load and examine the dataset, which contains reviews from Google Play Store to understand its structure, contents, and identify any issues if there are. The next step is data processing. Here, we clean the data. We clean the dataset by removing unnecessary characters and irrelevant information. Then, punctuations and punctuations and mentions like at the rate, username are removed as they don't contribute to any analysis. Then replacing null values. Null or missing values are handled to avoid errors during the processing. Coming to removing HTML tags. If there are any HTML tags in the text are removed to focus on the raw content. Coming to label processing here in the step, we convert categorical labels like emotions or sentiments into numeric values using label encoding to make the data suitable for machine learning models. The next step is oversampling. That is, we have used smooth technique for that. That means synthetic minority oversampling technique. That is nothing but smooth. It is applied to balance the data set by generating synthetic samples for the minority class, improving the model performance. Then here comes the tokenization of the data. Here we convert text data into numeric form based on the importance of words. And the count the occurrences of each word in the text and convert into a numerical representation. Then the next step is visualizing the data. Here we display the sample outcome. We visualize a few samples to understand the data better, and a word cloud is generated to display the most common words in the review. Then we select the features. Here we select the most relevant features that contribute to predict the emotions or issues based on the reviews. Then we split the data into train and test. Train set is used to train the model and test set is used to evaluate. Then we choose a suitable machine learning model and we initiate them. After initiating, we train them on the trained data set. After that, we select the best performing algorithm. We save it for the further prediction in the front end purpose. Coming to the front end, a user-friendly front end is created using Flask framework, which allows users to interact with the system, and it also includes registration and login features using a SQLite database for user management. And then the train model and the tokenizer are linked to the front end, enabling it to process new reviews. Coming to user gives input, here user inputs their feedback or review into the system through the front end interface. Then that input is tokenized, breaking it down into smaller parts for the processing, and it is fed to the train model for predicting the emotions of that particular message. And topic modeling is used and it is applied, which will help to identify the most relevant words in the review, providing insights into the common issue or themes. Then the predicted result, along with extracted topics or insights, is displayed in the front end for the users to see. So this is how we have implemented the project. Coming to the algorithms used, these are the algorithms used in this project, which is support vector machine, random forest, logistic regression, MLP, multinomial naive Bayes, KNN, ADA boost, voting classifier. And here we have used this extension model, which combines boosted decision tree, bagging random forest with the meta model. So this is all about the algorithms. Moving on to the requirements part, to implement this project, we need basic requirements, which are hardware and software. Coming to hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Then coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, backend framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. This is the overview of the project. Now let us execute. To execute, we need to open the code folder which contains source code files. So let us open it. These are the source code files in the code folder of the project. Let us understand each of them. How will they be used in this project? In the first folder, we have the dataset that is used in this project. That is the Google Reviews data, which is taken from Kaggle. So these are the different features. So here, these are different features. So here we have all the features. The data will be completely pre-processed. Let's close this. Let's get back. And this is the process data. After pre-processing, after removing all the unrequired values, after removing all the null values, and after doing pre-processing, here is the data set that is used to train the models. Close this. And here in the static folder, we have files related to CSS, JavaScript, and Bootstrap files, which are important for the visual appeal of the project. Coming to templates folder, this folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. Coming to app.py file, this .py file contains the information related to front-end logic of the project. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have model files, which contain the algorithm information, and this will be loaded into the project code during runtime of the application. This is the notebook.ipynb file. This is a Jupyter notebook file which contain the combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And here we have signup.db file. This file is a database file which is used to store the user information. And here in the sample file, we have the test cases. Now let's execute. So copy the path of the code folder from the address bar of the file explorer. So I'm copying it. Now open the Anaconda prompt. Here give the command cd followed by the space. Now paste the copied path and now click on enter. Here if you observe, current directory is changed to the code folders path. So by giving the cd command, current directory will be changed to the specified path. Now compile the app.py file. So give the command python space app.py. Now click on enter. So this command will execute Python script and perform runtime check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the localhost 127.0.01 and the port that is 5000 unless configured differently. Now we have to copy this local link provided by the Flask framework and paste it in any web browser. I'm copying the link. I prefer Google Chrome, so I will paste it in that. Paste the link here. Click on enter. This is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. Now we need to register first. Click on register and enter all the registration details if you are registering newly. I have already registered, so I'll directly sign in. Click on sign in and fill in all the details. So I'm giving username and the password. Now click on login. We have logged in successfully and we are redirected to prediction page of the project. This is the prediction page of the project. Here you can see text box, right? In this, we are supposed to provide the text that we have in the sample file. Let us open the sample file. Initially, I have mentioned you related to target that we are going to predict, right? So here we are going to predict 4 different types of classes that are nothing but anger, disgust, fear, and sadness. So first, let's apply filter to the sadness text and see whether the application will correctly predict it or not. Let's copy this text, get back to the application, paste it here, and now click on predict. So this given input, it will be pre-processed at the backend, and then it will be fed to the train model. Then train model will be giving us a detection. That is a prediction. So this is the message that we have uploaded. This is the text that we have given. And here after prediction, we got prediction that emotion of the posted review is sadness. It seems to be sadness review. And here the topic for the paragraph is most dependent upon these words. This is the review provided by the user for an particular Android app. And here is the prediction. So the user feeling sad about that app. And these are the important words that are these are the most dependent words for detecting this sadness. Now let's try predicting the other text. So let's try predicting this one. Paste it. Now click on predict. Here, this is the given review related to an app. It is app related to grocery. And this is the review given by the user. And here we got prediction as it seems to be sadness. So user is sad about this app. And here is the most dependent words to predict this sadness. Let's try giving the other classes. Let's try giving the fear. So let's copy this one, get back to the application, paste it, click on predict. Now let's see whether it will correctly predict it or not. So here, this is the review that we have given. After giving this review, here we got the prediction that user feels fear. So here, based on the posted review, it seems to be fear. It means that the user is afraid of this app. And these are the words that are dependent for predicting this fear. Now let's try with the other message. Let's try with this one. Copy it, get back to the application, paste it, predict it. And here we got the same prediction, that is fear. Now let's check with the two more classes. So select discussed, click on that and click on this. Copy it, get back to the application, paste the text here, click on predict. So here, this is the uploaded review. And here we got the prediction that emotion of the posted review seems to be disgust. That means that user who is using the app is feeling disgusted about the app. That is why it is predicting as disgust. And topic for the paragraph is most dependent on these words. Now let's try with the one more tweet of the same class. Let's try with this one. Get back to the application, paste it. So here we got the prediction as fear. Now let us move on to the last class of this project. That is anger. Now let's try with this. Get back to the application, paste it, click on predict. So here, based on the uploaded review by the user, here we got the prediction that user seems to be anger. So user is anger, frustrated about the app. And topic for the paragraph is most dependent on these words. Let's try giving the last case. Copy it, get back to the application, paste it. Now click on predict. And here we got the prediction that user seems to be anger based on the given review. This is how we need to execute. Now let's check with the graphs. Click on graph. So the first graph which we have is the sample outcome graph. This shows the class distribution of the target class of the project. Here on x-axis, we have all the targets that we have predicted, all the classes that we have predicted, and on y-axis, we have the count of each class. Here, if you observe, discussed is, they are in very few count if we compare it with the angle, fear, and sadness. And also sadness is also of very few count, only fear is having the highest count. As they are very low, we are using SMOTE technique, that is synthetic minority oversampling technique, to address this class imbalance. Moving on, this is the word cloud that we have generated. And this is the accuracy comparison graph. Here on x-axis, we have accuracy score of each algorithm, and on y-axis, we have algorithm names. These are the algorithms trained on the data set to predict the user emotions related to the app review. And this is the precision score. This is the recall score, and this is the F1 score. Here we have for the TF-IDF vectorizer. So here on x-axis, we have accuracy score, and on y-axis, we have all the algorithm names. So after applying TF-IDF vectorization to the data, this is the scores that we have got. And this is the ROC AUC curve graph. So these are all the graphs that we have generated. Now click on log out. In this way, just by uploading a user review related to app to the system, to the application, it will give the prediction what is the emotion of that particular user by using that app. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.